Hi guys, I'm Rushian. This video is all about analyzing the open access journal which is related to a floating point architecture. Let's start. This is a brief information about me and the course this assignment belongs to. This is my name and my registration number. Computer Organization and Architecture is the course which this digital assignment belongs to. This is the course code and I am doing this course under faculty Dhanbal. Coming to the point, what does this DA is all about? It is about the analysis of a floating point unit architecture from any open access journal. The open access journal which I chose for this assignment is Analysis of Effectiveness of Power on Refined Numerical Models of Floating Point Arithmetic Unit for Biomedical Application. It is generally a journal which describes about low power consumption in biomedical applications. Firstly, how did I gather information? Most of the information to answer the questions given in digital assignment 2 are in my journal paper. Other than that, I searched many online sites for block diagrams and Drawio for sketching diagrams and some other online famous websites for transistor level diagrams. Coming to the questions asked related to analysis of floating point, first one is that explain how the selected paper related to the COA syllabus. So first of all, I compared all the topics discussed in our course with the journal paper and tabulated it. Like what are the architectures are existing in my paper and with related to COA syllabus, etc. And I also gave some information about IEEE floating point numbers. Coming to the digital assignment, this is my digital assignment for analysis of floating point. For first question, I given some information related to the floating point arithmetic unit and also how it is related to our COA syllabus, and I tabulated it, and some information related to IEEE 754 floating point numbers. Second question is to draw the existing architectures discussed in the paper using appropriate raster graphics editor software, and it should be in EPS file format. I gathered information for this about some existing architectures in my journal paper. So I searched about those architectures and took notes and gathered diagrams from different online websites. For EPS conversion, I used an online app called EPS Converter. That is, this is the EPS converter which I used to convert the JPG forms to EPS form. Here you can like in target format you can convert any type of format into EPS, and you should have a EPS viewer in your PC to view the converted EPS format. So for that I use this EPS viewer and I downloaded it in my PC so that I can view the EPS files. Coming back to DA, here existing architectures which I found in my journal paper are Power 1 floating point unit architecture and Power 2 floating point unit architecture. So I searched for the information related to those existing architectures and block diagrams from online sites, and I used Drawio to draw the flowcharts and also block diagrams for this assignment also. This is how I took information about existing architectures and I answered the second question. Coming to the third question, it is given that to draw the tabulated results and graphs using Office Suite, and it should be also in EPS file format. For this question, the tabulated results and graphs, of course, they are in my journal paper. I found the following results there, and for drawing graphs, I used Office Suite and also online tool Drawio. Okay, to find the graphical results and tabulated one, this is my journal paper. And we have the tabulated results at the end of this is my floating point unit architecture, and these are the results. This is for delay and power consumption table for different types of unit, and this is for existing and proposed architecture graph comparison, and this is for parameter of refined multiplier variations, and this is the graph of the result. So coming back to my DA, third question, draw the tabulated results and output graphs using Microsoft Office Suite. This is how I tabulated the delay and power consumption table, and the output graph is drawn using Microsoft Office Suite and also using Drawio. This is for parameter of refined multiplier tabulation, and this is the output graph for that. This is which is drawn in Drawio app, and this is how I tabulated them. Problems I faced while answering this question is nothing but while converting the JPG diagrams into EPS format. because the graphical results did not come as expected. So that is what the problem I faced. Coming to the fourth question, given that to draw the proposed architectures discussed in the paper using diagramming and vector graphics application software. In my journal paper, a new architecture for less power consumption is given. As it is the latest journal paper, they propose a new architecture which has some adders and some base buffers to consume less power. So I used an online tool Dryo for drawing these graphs, and also Microsoft Office suite. Coming back to my DA, fourth question, proposed architecture. This is the information that is given in journal paper about their proposed architecture for less power consumption, and this is the floating point architecture which I shown you in my journal paper. This is the floating point unit architecture given in my journal paper, and I drew it using Dryo.io. Main difficulty I faced here is, as I already mentioned, that it is a new architecture. The gathering information became difficult because it does not exist anywhere, and also it has few floating point adders with the dual paths and also some multipliers. So gathering information became difficult. Fifth question is given there to draw the transistor level internal diagrams using electronic schema capture and simulation tools. Here I used online sites to get the internal diagrams which are mentioned in my journal paper. I also used Wikipedia for some information related to my internal diagrams given, and also for transistor level diagrams. Coming to the internal diagrams question, according to my journal paper, I have the internal diagrams like full adder circuit designed with 6-tree structure and also carry save adder. And coming to the floating point architecture, I have some buffer and floating point operation stack and also registers. So these are the internal diagrams which I choose to draw in my digital assignment. And coming to my DA, these are the transistor level diagrams which I took from online sites for full adder diagram and carry save adder, and also for operation stack as well as tri-state buffer and decoder. These are the internal diagrams which I choose. The problem I faced while answering this question is finding transistor level diagrams. Why? Because there are different types of transistor level diagrams for the given internal diagrams. So finding the perfect transistor level diagrams became difficult. Coming to the sixth question, given that to compare the proposed architecture with existing architecture in your reference books. For this, I used the textbook given for us for COA modules and also some other online sites for tabulating the differences between existing architecture like Power 1 and Power 2 with my floating point unit architecture. Coming back to my DA, this is how I answered my sixth question using textbook related to COA syllabus and also using online sites. Differences between existing architecture and proposed architecture in terms of power consumption and also clock synthesis and accuracy, also in terms of speed and shifters and precisions, and also in terms of area. Coming to the seventh question, given that to list the advantage of proposed design over the existing design. So compared to the existing design, my proposed design has many advantages as mentioned in my journal paper in terms of less power consumption, also in terms of area based and many more. Coming back to my DA, this is how I answered my seventh question. Advantages of my proposed design over existing design. In terms of larger area, it is advantage. It has an advantage, and also in terms of digital signal processing applications, also in terms of signal process, and in terms of precisions than fixed point processing. This is floating point processing unit, so it is more. It have larger precision than fixed point processing. Also in terms of cost, I differentiated advantages over existing design. Coming to the eighth question, given that to list the merits and demerits of proposed and existing techniques or hardware. For this question, first of all, I found hardware components which are required for my floating point architecture, and I took the block diagrams of it, and also I took some merits and demerits of existing architecture from tutorials point. Coming back to my DA, eighth question, list the merits and demerits. I differentiated the merits and demerits for proposed techniques and existing techniques in terms of floating point processings and fixed point processings, and in terms of area, and also in terms of speed of arithmetic operations, and also in terms of cost and size of chip, and also complicated hardware equipment. Yeah, these are the some of the hardware models for my proposed design. This is a hardware model for addition or subtraction, and also for multiple and division. These hardware models are used in my proposed floating point architecture, which makes it easier to to consume less power. Coming to the ninth question, this is the application of proposed design. As earlier I said, my chosen journal is based on biomedical applications. How less power consumption is going to happen by using present floating point architecture in biomedical applications. So in my journal I have points based on biomedical applications. Coming back to my DA, the application for this proposed design is biomedical devices, as I mentioned earlier. They are to have very sensitive external noise. We can use it in biomedical applications. Also, the main idea is to design the FP processor in which floating point arithmetic operations is improved in terms of power and area, and the arithmetic unit of the processors is defined to perform operations in floating point representation for accuracy, and this is also used in radar systems also, and FPGA are used here so that the hardware can be constructed using techniques. So the architecture was changed with low count of transistors and less area. So basically this is where low area and low power consumed and low count of transistor based model which is used in biomedical application. Coming to the final and last question, 10th question, draw the flowchart or algorithm or transistor level circuit proposed in the design. Coming to my journal, the proposed for proposed architecture there is no transistor level circuit proposed, but coming back to algorithm, we have algorithm for multiplication and division process like arithmetic operations, and also flowcharts related to them. Coming back to my journal, this is what I mentioned you before. This is the floating point addition or multiplication flowchart which is given in my journal, as well as the floating point division algorithm which is in form of flowchart is given. So I took the reference of these two and I used Draw.io tool to draw the flowcharts for these proposed algorithms. This is how I mentioned the algorithm for addition, multiplication, and also for division, and answered the 10th question. Thus, by proposed journal on floating point unit architecture, I am able to describe all the above questions effectively, and I answered all the 10 questions, mostly from my proposed journal, which describes about the low power consumption method and which is an application for biomedical devices. The link related to the online tools which I used for drawing and sketching diagrams, and also for the journal which I used is given below. Thank you.